So I think we are good to start. Welcome, dear guests at M&M Software. We have announced back a few weeks back. We have announced that we will open our AAS.TwinEngine frame. So this is the day today. So we will have this opening session into the day, and during this session you will see what it is. We will take a deep dive into the technology, how you can use it. But let's start first, very briefly, a few words about M&M Software. We are about 350 people. We are located at 4 locations, and you will have a few of us in the session today. So we have speakers from the development team. Me, Rolf Engesser. I'm lead of Competence Center Industry 4.0 and Digital Twin, and others will then briefly introduce themselves. They all have their parts during this session. During the session, then the microphones and the webcams will be inactivated. So all the questions that you will have during the sessions, please write them into the Q&A section of F&A, Fragen und Antworten. Later at the end of the session, can come back to answering that questions. Okay, so the agenda. We take you across the goals, the inspirations that was driving us, why we came up with the AAS.TwinEngine. Then we will take a look into the architecture, how we designed it. Then you will see the GitHub, because we are open source, or it's available on open source. That is why you will find all the resources and repositories on GitHub. Then you will see a live demonstration, so you can get some hands-on experience how you can use the AAS.TwinEngine. I will give you an idea of how we will develop the roadmap of the future directions of this twin engine, and finally we will have then the chance to answer your questions. So, but let me first start with the twin engine itself. What's the vision behind? What's the what we consider is the what makes it unique? Left side is you usually, when you want to create a digital twin for an asset, for a product, we should cover the cycle of the asset. That means during the life cycle you will have diverse systems where you're maintaining the data for that asset. Systems in your IT environment, ERP system, CRM system, PLM system. PLM will be the very first one when you're designing the product and so on. And then you also, once you have your product is in use, then you will have operational data then coming from OTIL. Then you will have want to access let's say your assets. So you have a diversity of systems where you will get, and you should have, or you will have, an ETL process established where all those diverse data systems will be transformed and unified into let's say a unified data model, because all those systems are so far you have to break up that silos and bring into one common data model. And this is where then the AAS.TwinEngine comes in, because now we can plug into such an ETL data platform or data integration platform, you will have you can have a plugin which then connects and then does the interfacing to the AAS modeling out there. You will need this for interfacing to external partners, to comply to let's say to standards out there, which also takes you to some exchange on data spaces and so on. So what we found is that what you can see on the left-hand side, usually you already do have such a system in place. And this is why we would plug into what you have already. If you do not, then also here we can help out, because then we can support you with data solutions that would bridge this gap for you.
Sorry to interrupt, Rob.
Would have is that we would have the need to create multiple connectors to all those diverse systems individually. This differs from approaches that here. So in the end, this plugin is very much based on semantic reference. It also means on the left-hand side, there is no need that anybody who is connecting to such systems need to care about. This is what you can see on the left side. This is all the components in your infrastructure. Very briefly, this is the IT systems, that is the OT systems, ERP, CRM, and so on. And this is the ETL process established usually. Sorry that we missed to switch on or share the screen here. Okay. We will later see, as I told you, there's a plugin, and usually you would require one plugin. We will take you through in the demonstration part. We will have a DPP plugin, which can be used later on for a DPP solution that you know, which is something that in the future is obligatory for all products in the EU, starting with the battery passport, but later on also other product groups. So with this said, I would like to hand over then to Markus. So he will give you some more insights on the goals behind.
So then, hello everybody. I'm very pleasant to present to you the goals and what makes the AAS.TwinEngine unique, and to give you a bit of an overview over what we thought and what we came up with. So I'm Marcus. I'm here at M&M responsible for a lot of the technical questions and domain questions around how to use asset administration shell, what is asset administration shell, and participating in the IDTA and in other working groups. And so therefore, I was heavily involved in bringing up like the core ideas behind this whole framework. And that's also the first key point. We're talking here about an integration framework. Rolf already mentioned that we're fully aware that you already have something, some systems in your company, and what you need is something that just plugs into your existing data systems and your landscape. So that's what we wanted to achieve, and therefore what we did is we created our framework to design is to create the asset administration shells on request. This might be a bit different, or this is really different to a lot of other solutions or open source solutions that you can find out there in the market. Oftenly, we have the issue that when you want to create asset administration shells, what you see is then that you need a repository, and a lot of the solutions implement the repository as a database that is storing the duplicated data of that as an asset administration shells. So first you have your original data, like I said, you already have systems there. The data must be somewhere in your systems. Then you have a process that transforms it into an asset administration shell, and in the end, you store it somewhere. And that's exactly what we did not want to do. We wanted to give out the AAS just whenever you access it and create it on the request. This has a huge benefit over the other described process where you pre-compute AAS and then give it out later on in a separate repository, because we now are not an isolated component. We are now really just a thin access layer on top of the existing systems, and we therefore can always provide live data. This gives you the ability to always keep your AAS in sync with the original data. If you replicate the data, or if you start data replication as AAS, you will quickly run into the question: how do you keep that in sync? How do you bring in updates into the AAS from the original systems? If you delete something, how do you update that? And that's something we really wanted to avoid, also to avoid efforts. I mean, implementing all that update mechanism takes time. That's not so easily done. You need to bring in a lot of thoughts and how to do that properly. And therefore, we want to mitigate those efforts. We want to use whatever is there, whatever update mechanisms are there, and just bring in the live data. The core part, how to access the data, is then a plugin. A plugin really is the part in the whole framework that is designed to access your data, because plugins, they have a defined interface. So we have our core components. They access the plugins through that interface. And therefore we can abstract all the core components and create custom plugins to enable them with custom logic. So whenever you want to access any kind of data source, you can just write your own plugin and then access the data and use that. So the main idea behind that was that the core components now, they know about asset administration shells, but the plugins, they don't really need to know about that. The benefit is also, if you think of authentication and authorization, then the existing databases, they already have access control. They have some sort of user management, and the plugins, they need to understand how that works, how to access the data, and how to properly authenticate the users. So that's why the plugins are so crucial. The plugins, they cannot be generic, because the domain where they run in is not generic. You always have to have some custom logic in there. So this leads over to the security concept. The security concept here is a defense in depth approach. So the main idea here was also we provide an integration framework. We don't want to duplicate efforts. Implementing security is always a lot of effort, and it also has a high risk in introducing any errors or so. So therefore, we wanted to keep it as slim as possible and to reuse as much as possible what is already there existing in the company and user landscape. So we found out that there are like 3 interesting points that need to be kept an eye on in order to have a proper security, and it is the first thing definitely is the data. Like I said, the plugins, they access the data sources. The data sources, they have access control with them. So the data is already protected, and you need to use the protection, or you can leverage the protection here that it's already there, and then just use the plugin and authenticate the client request against that data source. With that, also here, in comparison with the data duplication in a separate repository, we also have the benefit that the data is already protected, and we just reuse that protection, and you don't have to come up with any new concept on that. And I think that's true. The other point is definitely we provide an AAS API, and like with any other API, it should be protected by some form of API gateway. For the API gateway, it's the same thing. API gateways are normally there in a company. Most companies have an API gateway to protect all their APIs from DDoS attacks or do access logs and all kind of that stuff. So they're really crucial. But also something that's normally present and that we can just reuse and bring in a lot more security to the whole framework. And the last thing is that we work with templates. We will see that later, how that really works with the templates. But in general, it's quite easy. You define once what kind of template you want to use, how the submodel should look like, and in the end, it's filled up with data from the plugin. The templates, they are stored in a template repository in our AAS.TwinEngine, and the template repository there also offers the possibility to do some access control. For example, you can restrict which user role can access some properties, for example, billing information. But of course, it's just a template, so it does not know anything about the user or the context. And the authentication, it can just say this user is authorized to see billing information, but whether he's allowed to see the billing information of that company A or company B, that can just be decided when the data is there. So that is also on the data part then, and in the responsibility of the plugin. So on the last big point is then that we wanted to create a data-driven architecture. AAS is all about data, so we really wanted to bring in some new ideas and to let the data work for itself. And therefore, we came up with this approach where you can automatically match AAS properties with data points or any submodel elements with data points. The core or the main goal behind that was that we wanted to be able, or we want to enable you to use IDTA templates without any modification and still get your asset administration shells for the products and the assets that you have. We did that with a focus on semantic IDs. Just a quick recap on semantic IDs. So semantic IDs are a big point in the whole AAS ecosystem. For example, on the left-hand side, there you can see the manufacturer name. And I guess if I ask anybody of you, you will all be able to give an explanation what a manufacturer name is. But the explanations will vary depending on who you ask. And so there are dictionaries out there who also already did that definitions. And they bring in some identification, some semantic ID that is then attached to a property or to any other submodel element within the submodels and the asset administration shells. And they attach then a definition, what exactly does this manufacturer name mean, and what how can this be understood? This brings a universal understanding of data in general, but for you implementing the AAS.TwinEngine as a framework, it also brings the benefit that you can bring now in the semantics to your existing data source and therefore enhance these data sources. I already had some discussions with people here at the data and AI department, and they were really excited about the idea that you can add to data points a semantic ID and this description, because with that description, it is now possible to also train AI models on that and leverage that semantics. So in summary, we have the possibility here, or we rely on the semantic IDs, and we have the possibility to bring in that semantics back to the existing data sources, and also to enable other use cases with that, and not just to leave the semantic IDs there and untouched and without any benefits to the rest. So with that said, I will now hand over to Ankit.
Yes, thank you, Marcus. I hope my screen is visible, all of you. Yep. Okay. Okay, so I'm 𝐀𝐀𝐒, and I'm responsible for AAS.Twin and its component architecture. So today I'm going to walk through the high-level architecture and the data flow of AAS.Twin across all the components.
Cannot hear you. Could you?
Hello? Now? Can you hear me?
I can hear you.
Yes. Hello? Yeah, so okay. All right, so I will walk you through the high-level architecture and the data flow of AAS.Twin across all the components. As you can see in the diagram, at the center of the diagram is data engine, which is the core component of AAS.Twin and also responsible to build asset administration shell responses at the runtime instead of storing the data and its memory. At the top, we have AAS and submodel template repository. This repository store the templates, for example, a submodel templates that define only a structure, but they do not contain any value. I will also explain how data engine is responsible to fill the values inside the templates. Now, going further in the diagram, on the left-hand side, we have plugin and data sources. The plugin is responsible to handle data engine request and get the user data from the data source. Here, the important point is data source is owned by the actual business owners or users. The business owners or business data means it could be any production data or ERP data or operational data, which store in their own databases and scattered at different locations. On the right hand side of the diagram, we have users and the applications who are responsible to consume a complete AAS data through a data engine. Also, in the diagram, if you can see in the center, there is application gateway in the front of data engine. The responsibility of the application gateway is to handle a request coming from the external user, such as API users or the applications. All requests first go through the application gateway, which takes care about the routing and also security before forwarding it to a data engine. So this is the overall high-level overview of each component of AAS.Twin. Now, I will walk you through the how data flow works across all these components and how user finally gets the complete AAS. Okay, so when user request, the request come through application gateway through a data engine. Now the data engine then loads the request template from the template repository, as mentioned by Marcus earlier. At this stage, when data engine gets a template from the template repository, the template contains only a structure, but there is no actual values inside it. So what happened after that? The data engine requests the required data from the plugin, and the request sent to the plugin in the form of JSON schema. Now, at the plugin side, the plugin retrieves the data from the data source based on the request it received from the data engine and returns the value back to the data engine. Now, what is the responsibility of data engine that I mentioned earlier? The responsibility of data engine, it gets the response from the plugin, it fills those values into the template, assemble a complete asset administration shell, which is then returned back to the user. Right? So far, we have looked at the architecture and the data flow at the high level. In the next slide, I will show how this request response flow works using a concrete example. Now, let me explain the important design idea behind how data is exchanged between data engine and plugin using one example. So here, I will explain you about plugin contract. As mentioned by earlier, before we go ahead with the example, I hope you all are familiar with the semantic ID in the context of AAS. So basically, it gives you a standard meaning to ASS data elements or submodel elements. So we come up with the idea that plugins should work purely with the semantic IDs. By doing this, the plugin does not need to know anything about AAS structure or the templates. Templates define the structure and plugin only focus on providing the data. Let's move it one of the example here. So it will clear how flow works. So when the system starts, the data engine already know where the plugin is and which endpoint it exposes. When the data engine starts, it asks plugin that which semantic ID it supports, and then data engine stores this information in its memory. Now, let's assume that user or application requests a nameplate submodel. Now, what happened after that? The data engine receive the request and fetch the nameplate submodel template from the template repository. Now assume that this template defines the element like manufacturer name or product name, serial number, or any company information inside the nameplate. At this stage, the template contains only a structure and the semantic ID, but no actual values, right? So what happened after that? So the data engine extract the semantic IDs from the nameplate template. For example, if you can see in the diagram, it defines that manufacturer name is represented by the semantic ID. Start with something like 0173, as you can see in the diagram. The data engine then sends a JSON-based request to the plugin that simply says, this is my semantic ID. I need a value for it. Now at this stage, plugin receive the request and look into the own data source. At the plugin side, the semantic ID is already mapped with internal data. So the plugin simply retrieves the corresponding value from the data source. So if you can see here from the example, the manufacturer name, here it is M&M Software. Now this is what plugin part is. Now the plugin send the values back to the data engine. The data engine responsibility is to fill the values into the nameplate template and assemble a complete nameplate submodel. Here data engine is fully assembled nameplate submodel with real data. Then it returns back to the user, exactly shown in the diagram. So this is the complete data flow of the ASS Twin and its component. Now, the key idea is when the system starts, data engineers already know where the plugin is and which semantic ID it supports and store this information. And because of this, when runtime requests came in to data engine, the data engine is already knows that which plugin can provide which semantic ID. So there is no discovery or guessing at the runtime, only a clean, predictable interaction based on the defined contract between plugin and the data engine. To summarize all of this example, so the key point is template define the structure, semantic ID define the meaning, plugin provide the data, and data engine assemble a complete AAS at the runtime, right? With that, we have seen how ASS Twin works internally and how data flow works across all the components. In the next slide, I will show that how data engine fits into the broader open source ecosystem. So this is a diagram shows that ASS Twin is not isolated component. It is designed to orchestrate and integrate with existing open source AAS tools. The orange component, if you see in the diagram, which is Eclipse Bazex based component. This includes AAS submodel, template repository, the ASS registry, and the viewer tools such like AAS Web UI. The data engine integrates with these components seamlessly and use them for template management and registry services. If you can see further in the diagram, there are sky blue components represent ASS suite, which is the component provided by the meta model. Here, I just want to mention one point is that this is just an example to demonstrate that data engine can be integrated with other AASS implementation as well. And it can utilize their capabilities and feature as a part of overall ecosystem. As we can see in the example, we could have the meta level viewer and reader as well as a part of orchestration of data engine. Now, at the center, the data engine acts as an integration layer, connecting templates, plugin, and UI tools. On the left-hand side, the data source remains fully independent and customer-owned. On the right-hand side, users and APIs or consumers access AAS data through viewer or web application, just like any other standard AAS setup. The key takeaway from this is ASS Twin complements the existing ecosystem. This makes ASS Twin a strong foundation for open, interoperable, and a standard digital twin solution. Yeah. So with that overview of the ASS open source ecosystem, I will hand over the presentation to next speaker, Kartavya. He will talk more about ASS Twin in our GitHub open source system. Thank you, guys.
Thanks, Ankit. Hope my screen is visible. Okay.
Yes, Kartavya.
All right. Yeah. Hi, everyone. I'm Kartavya Shukla, working as a project lead in M&M, and I'm closely working with the development team and assisting Rolf with the requirements. What I would like to give you a quick overview on the how GitHub organization is structured. Right here, I'll be covering a couple of areas. Right, since AAS.TwinEngine is an open source project now, what we have done is we have designed a repository layout to be clear, easy to navigate, even for the first time contributors, because that's where the contributors will come in and will have the idea. There are three areas that I'll be covering here. One is the repository part, right? How the repository is structured, right? An overview of the repository as well. So let me take you through the repository overview first. Yeah, this is our organization on the GitHub repository, and down you can see there are two repositories, that is public, data engine, and DPP plugin, right? So the three areas that I was talking about, let me start with the engine first, data engine. So this repository contains the core 𝐀𝐻𝐿 components, including data, implements the IDTA align AS APIs, and handles the runtime orchestration logic. We have seen the this some bits and gets into the previous slides. AAS.TwinEngine data engine is the core service of the data TwinEngine platform that dynamically generates the AS shell using IDTA align APIs. It combines the standardized AS templates with the live data retrieved through plugins and enable the flexibility and interoperability, digital twin integration, right? This makes the data engine as the central building block for runtime AS composition and data orchestration. And let me take you through the data engine repository quickly. Here you can see what we have covered here. We have given a guideline for that, some overview on the data engine. What are the features that we have covered as a part of data engine repository? Data engine AS generation flow from client to plugin, how data flows back and forth, step-by-step process as well to fetch the template, extract the semantic IDs, and also a quick start guide so that contributors can easily run these commands, clone the repositories, and they can start contributing to that. Okay, let me take you back to the another repository, that is plugin. So this repository shows how external data sources can be connected using semantic IDs. Plugin are intentionally separated from the core engine so that user can extend the twin engine without modifying the main code base. Here, this is DPP plugin that we have created. You'll see the same structure that we have used here as well. Overview of the DPP plugin, how it works. Then we have also added a feature overview like schema-driven API, semantic ID-based data mapping, JSON-based communications. Some use cases we have also mentioned. And what are the DPP submodel that are being supported by this plugin at the moment, right? So like starting with nameplate, contact information, handover documentation, technical data, and carbon footprint. So these are the submodels that are being supported by this plugin. And again, you'll see the quick start guide, some Git commands for contributors, installation and setup, local development setup, how can I create it? So some commands related to that, configurations, what are the environment variable that I need to set? So as a developer, I can have clean and really good idea. Quick start. The next part, third part, which is the examples. Now, when we look at the data engine here, you will see the example. So what we are covering here as a third area that I mentioned. Here we are having a working example, a demo setup. So this helps user to quickly understand the end-to-end flow from template to live data. Here again, you will see some instructions. What are the submodels that are included? What are the quick start, prerequisite, again, commands? What are the architecture and services that are being used? Creating or changing your ASS data in case you would like to have your own data using Postgre, that we will surely be seeing in the last part of the demo. So this gives you clear idea how that can be done, right? And some troubleshooting if it is required. So this gives you a clear idea, clear guide, and with this sample, you contributors can easily start. So overall, this structure keeps the platform modular, extensible, and contributor friendly. Now with this, since we talked about repository structure that covers the where part, right? I would like to also take you through the how part, which is through documentation that we have, right? So here I'll be covering 5 areas: wiki documentation, developer guide, plugin contract, set up your own environment, and contribution guideline. One thing is for sure, the goal is here to make it easy to discover, build, extend, and contribute safely. Considering that goal in mind, this is how the structure has been defined, right? So let's start with the how part, how we capture and share the knowledge, that is wiki. This is our landing page wiki. The instruction, the documentation is very neat and clean. Here you can see the areas that we have covered, like architecture, features, core concepts, glossary, right? How does the data engine solve the problem? Architecture diagram again, the design principles that underline the data engine. Right. On the right hand side, you can see the core concept that are there, like submodel repositories, submodel registries, right? What are the submodel elements that are being supported by data engine as of now, right? And some guideline for contributors. How can I start with the development? So this gives you the clear idea on the instruction that needs to be followed, right? And we can think of it as a front. Start here before diving into the code, so that I know to and flow. I'll have the clarity. To the developer guide. Next point. Now this is it's a practical handbook, right? Who should use it? Some instruction around setups, and what are the services that we can include. So that is written over here, very well documented, a step-by-step guideline. How can I clone it? How do I navigate? How do I start the Docker Compose? And what are the services that are going to be included? Starting with data engine, then template registries, template repositories, and one plugin service as well. We have already seen this example folder, so that once you are done with this developer guideline, you can easily switch back to demonstrator setup. And here again, you can follow the same similar examples, and you can have your own running environment up and running. Okay, with that, let me get back to you again on the presentation. The third point is plugin contract. Now, the core value of AAS.TwinEngine is extensibility, and the plugin contract defines how external modules integrate safely. Right. So here in this plugin documentation, what we are covering is the some instruction around what is the purpose, some plugin manifest that we are covering over here. What is the structure that we have for manifest file, and what are the endpoints? Like manifest endpoint, get manifest plugin. What are the methods, route, query parameters, request, responses? Now these are structured in a way that any contributor will have less amount of queries when that contributor starts contributing to the organization. Right? The structure is almost similar. Some more endpoints like metadata. So here we'll have a shells, a list of cell descriptors as a return value. This is for single cell descriptor. How the structure is going to be, JSON schema, and some more endpoints. This is regarding submodel data. How can I query the submodel data? And concrete implementation of this concept is DPP plugin, right? And it implements the plugin contract expected by data engine, a concrete database schema for storing submodel and submodel element values. Right. The next point is how can I set up my own environment as a contributor? Let me take you through that as well. So this is again a clear instruction. How can the contributor can start? Right. So what are the prerequisites that that person needs to have installed on his or her laptop machine? Right. Prerequisites. Then some basic understanding on the project overview. How the when the person starts looking at the repository, how the structure is going to be. Then they build this, right? And then set up template repository or registry. How that can be done. Here we are also You can also have your own TED services as well. And
𝐀𝐻𝐻, your voice is breaking.
we are going with is it clear now?
Maybe it helps if you turn off the camera.
Yeah. Is it okay now?
Yeah, it looks good as of now.
Okay. All right. Sorry for that. Yeah. So I was talking about this one, option A and option B. So in case if you would like to use your own template service, what are the changes that you need to do? That is also shared over here. And at the end, how you can run your data engine API with this command, right? Again, we have shared the development workflow. What are the things that needs to be taken care by a contributor that is being shared over here, right? So this gives you as a contributor, this gives you a clear instruction, what needs to be followed in which way. Now the next part, the contribution guideline, right? This outlines how we collaborate, right? Branching, commit style, PR review. So what are the instruction that needs to be there, because it is also very much required. So the guidelines shared over here, a code of conduct, then what are the branching and pull request mechanism strategy that is being followed. So just to give an example, we are having develop and feature branch, right? As a contributor, if I would like to create some feature branch, what are the nomenclature that I need to use? How can I do that? So instructions are given here as well. And then testing and documentation. So this covers the contribution guideline, right? And to summarize everything, what I have shared in this slide, wiki tells you how, why, and what. Developer guides shows how to build and test. Plugin contract defines how to extend it safely. Environment setup gets you productive fast, and contribution guidelines keep the quality high and reviews smooth. With this overview of GitHub organization repository, I will hand over to Hardisha for the next part of the section.
Thank you, Kartavya. Hello, everyone. I am Hardisha, one of the developer from M&M working on the data engine and plugin ecosystem. My screen is visible, right?
Yes, Hardik.
Yeah, okay. So today I will be demonstrating you about 𝐀𝐻𝐻. As you all guys know, that 𝐀𝐻𝐻 is responsible for serving the API endpoint. So for the better visualization, I am using the BASX Web UI. Web UI internally calls the data engine endpoints. And data engine itself uses the BASX template registry, BASX template repository, and the DPB plugin. So DPB plugin is one of our repository which you have seen inside our AAS.TwinEngine organization. And DPB plugin works based on the plugin contract. It uses the relational database. As of now, we are using a Postgres SQL. And DPB plugin is also responsible for providing us a submodel data, which is used for the digital product passport. So let's move to the BASX Web UI. As you can see over here on the UI, we have a 3 product, which also coming from the DPB plugin. As you can see, we are getting the product related information over here, like specific asset ID, product image, everything. For each product, we are getting a different image and the values. Also, for the submodel, for each product, we are getting 5 submodel, which are from the digital product passport, which includes the carbon footprint, contact information, handover documentation, nameplate, and technical data. So for each and every submodel, we are getting a different value for each asset. As you can see, for the carbon footprint, for product 1, for product 2, for product 3. As you can see, we are getting a different values, which is coming from the DPB plugin. Also, You can see same for the contact information submodel. Like for the first product, we are getting 2 contact information, whereas for the product 2, I am getting only 1 contact information. So you can also see that over here. Same goes for other submodel template as well, like handover documentation. As well as for the nameplate as well. And the technical data as well. We are getting a different value for each and every submodel based on the product. Now, let's assume that I want to change some values in over here. Let's assume I want to change value for the manufacturer name for the product one. How can I do that? So as I earlier mentioned, we are using a Postgres SQL server. So for the visualization, I'm using a pgadmin for database changes. So let me jump to the database. Over here, you can see we have a different table, and I will be changing the values from the table. Let me just run the query. As you can see, for the product 1, I'm getting M&M Germany. I want to change it to M&M. I will just save the changes. Now, if I go back to the UI, over here, once I again request the manufacturer name, it's M&M. So as you can see, we can update and modify the data on the runtime without changing any line of code or changing any ASX file. So this is the one of the key features from the data engine. Now let's assume I want to change something else. Let's take example from the carbon footprint. Like I want to now change the publication date from the carbon footprint. Earlier, now it's 2025. Now I want to change that to the 2020. So I will just run the query. It's updated, and now if I again request the publication date, you can see we are getting a date as 2020. Let's assume for the contact information, I want to add one more contact information for the product 1. So the step is I need to first add one contact information inside a table, contact information table, and also I need to add mapping into the mapping table, asset contact information. So I will also do that. So first I will be adding one contact information. So I will be running this query, and we have added one contact information. Now I want to add the values inside a mapping table as well. So I will be adding the mapping for inside asset contact information table, and it's also done. Now if I go back to the UI and request the contact information again, as you can see we are getting a 3 contact information instead of 2. So on the runtime we can change and modify the data. Now one of other use case, what if I just want to update my submodel template? How can I do that? So let's take an example of nameplate submodel template. All right. I hope you are able to see the ASX Package Explorer. So I am using ASX Explorer to change and update the submodel data. This is also one of the open source application. Now I want to add one more property called manufacturer URL, as you can see over here. And I have added semantic ID for it, as well as I have added the value type over here inside the property. Now I will be using this submodel template and getting the data for the manufacturer URL as well. So one of the step is we need to add a column inside a database, and we need to change DBB plugin as well. So let's first change the values inside a DPP plugin. So now we need to add a semantic ID inside a mapping.json first. So I have added the semantic ID. As you can see, the dbu.asset, asset is a table name and manufacturer URL is a column name. And this is the semantic ID which we have added inside a template. So this is the same semantic ID which I have added inside the template. Now I need to also change the query for the nameplate submodel. So I will just change the query. I need to add manufacturer URL inside the query. I will just save the changes and I will recreate the image for the plugin. Also, meanwhile, we need to change the database. We need to update inside the database as well. So let me again go to the PG admin. As I have rerun the Docker Compose, I also need to add the server in the PG admin. So as I've earlier mentioned, we need to add column inside the asset table. So I will be adding one more column called manufacturer URL. And I will just add the data type over here. And the column is added. Now I also need to add data for that. So as you can see, we are getting null for data. I will be adding the URL of software over here. Now I will just save the changes. Meanwhile, in between, I have updated the template as well. So let's come back to the UI. And over here, for the nameplate submodel, now we have new property called manufacturer URL. And we are getting value for it like software. So that's it from the demonstration. I will hand over to the Rolf for a further presentation.
So now that you've seen all the capabilities of the TwinEngine, that you've seen the GitHub resources, and you have seen the hands-on demo, hopefully you have identified how it can help you to bring up your solution, your AS solution. And you might be interested to understand what is our future directions. So that is why I want to share this with you, that you have some idea for what is driving us here into future roadmap development. We will have demands coming from diverse directions. We will have customer projects using AAS.TwinEngine, and we will have demands not yet covered by the TwinEngine, maybe some enrichments, some additional capabilities. We will have demands coming from partner initiatives that we're driving some more ideas that we want to extend capabilities. For example, connect to data space frameworks and so on. And also for sure, we will have demands coming from the development itself. And so in the end, this is basic, and this is your chance how you can contribute. You will have a chance in the GitHub to raise your issues, your feature requests, and we will then bring it on the table and then take decisions on our priorities. For sure, you can also, if you plan to use it to develop your own plugin. Also, that is what you then can drive forward and we just need to make sure that it's really it's a match, it's fitting into the plugin architecture. So that is what we are planning here. Unless we do not have yet decided about the milestone, we will not publish such features upcoming. That is why we will not publish now or today, but in future, once we do have given this this commitment, then you will see some announcement, and then you can plan for your development. If you rely on some capabilities that's not yet there, that you can see, okay, it will be there in a few months. So that should help you for your internal planning. So this is now the moment when I would like to go back to the panel, bring all the speakers on the stage, and then I would go across the questions that you have raised during this session, and so you have a chance that your questions will be answered. If you have some further questions, don't hesitate, reach out to us. We will later share the recording of this session. Also, you will get some contacts that you can address your questions. Today, it's a very technical audience, so we will have technical questions, but also we'll give you some advice how you can connect on a business level when you want to get in touch with us. So, and when you think about some projects or some business cases that you would like to address. So both will be covered, but for the moment, we will focus on the technical questions. Okay, so we will ask the questions or read the questions that you have provided and then ask the speakers. So one question, what was coming, how do you map the information coming from diverse data sources not structured in AAS to the proper AAS property? If my data source is an OPC UA server and I would like to map it to the AAS submodel containing that value, is it hard-coded? I think Markus could be a question that you could answer.
Yes, that's right. Indeed, good question. It comes together with what we said earlier with the mapping of semantic IDs. So in the end, we never hard code anything, or at least not in the �TwinEngine framework, because what you need to do there is you would create a plugin that is capable of accessing the OPC UA server, and the plugin then would provide the corresponding semantic ID for this data point. So in the end, what you need to do the mapping between the semantic ID and the data point. That is pretty important. Like Ankit also showed earlier, how this is working in the background and retrieving the data, but the template or the like the core of the AAS.TwinEngine would never know where exactly things are coming from. They are always abstracted through that plugin concept. We have an interface that is clearly defined, and in the end, what you need to do is create a plugin that provides the semantic ID and offers it to the data engine, and the data engine will automatically then find that the correct plugin to retrieve the data.
Okay, thank you. Here's one, I think, Ankit, that could be yours. Can data engine be integrated if I already have my own registry and repository? As we have seen in let's say the setup that you require those to be set up. What if that already is there?
Yes,
maybe from other open AAS and solutions already there.
Yes, that is a very good question. To answer of this question, yes, data engine is capable of being configured in such a way that you can use your own repository or registry. As long they follow the IDTA standard or AAS standard, data engine can work with them without require any replacement. You need to just configure data engine in that direction.
Maybe one thing that I want to add to that. I think we did not really cover the registry part, but the data engine or the Twin engine also offers an endpoint to retrieve registry data, so shell descriptors. In general, it's designed like with the data requests through the repository. We're doing on-request creation. But like Ankit said, what you can also do is you can create a schedule and then, for example, schedule the creation of the shell descriptors and define a registry endpoint where the data will, or the shell descriptors will then push to. So you have both options. You can create the shell descriptors on request and use the Twin engine as a registry, as a primary source. But you could also do through batch exports, leverage another registry that is already there, and then we will just create the shell descriptors and push them to that other registry.
Okay. So there's one more. Next is somebody asking about the carbon footprint, obviously. What if the CO2 is not stored in the MES system, or if the values are only stored in the individual production processes? Means they have to be added together. What would the plugin report back?
In that case, you need to handle that already in a plugin. That was also one main decision that we took on the architecture and how we want to create a framework. Because if you have the need to calculate that CO2 value, and you need different data sources, or you need to aggregate in some form, then we highly encourage you to do that in an independent way, so AAS independent way, so that you have an endpoint in your data, in your system, where you can retrieve or where you store the data in your systems. And you would then create a plugin that reads the data from this data source where the final CO2 value is lying, and the plugin would then provide that value to the data engine. So the whole framework is designed to not do any aggregations, also any aggregations and other math, so that it needs to be done, has to be done in a plugin, and the plugin will then just provide the final value to the data engine.
Okay, thank you. Let's know about Ankit. Maybe you two can answer this. It's about the versioning support, because you know there is diverse versions out there, and you might have partners who are running their AAS maybe on the version 3.0, others on 3.1, which is an obvious conflict. If you might have some discompatibilities or breaking changes. So the question here is, how are different AS model versions supported? Is AS model conformity checking directly based on the AS schema? Is the model checker also made available? Okay, that's a critical question, or that's a good question?
Yeah. So as of now, I guess we only support versions of DPP submodels that we already have in the data engine. We already mentioned in the our GitHub repository. But yes, if there is some breaking changes, so we have to also document that one in GitHub repo.
Okay, there's one more question. Is there a minimal example to build a storage data provider plugin? The relational database plugin repository seems to be private. That's also a good question here. the DPP plugin that you've seen that Hardy was showing, that is actually it's let's say it's part of a relational database plugin. In fact, that we're planning to extend. For the moment, it is hard coded. This means that it is based on assumptions that or a database scheme that you would have to use, and you have seen in the demonstration how you could modify that, but that is nothing that we have yet developed and have not yet decided how, if that would be then also one of the public offerings. As you can see, obviously, it is open source, and the data engine we have the demonstration plugin and the internal testing plugin that you can use, and it's then up to future development who will contribute and add some more repository some plugins. So that is not yet decided which of those plugins we will then also develop and publish. It's also depending on how our customer are willing to donate or sponsor such developments that they have paid for to the public. So it's a very interesting point, and I hope in future we will have some very good news to all public that we will have good plugins that everybody can use, but it's not yet clear what will then be the future offerings on that. Okay, what about data systems without support of semantical references? Markus, I think that's a little bit into the direction of what the earlier question on OpenCUA, right?
Yeah, going the same direction. In the end, what we need is that the plugin provides the semantic IDs, that the plugin has some sort of mapping between semantic IDs and the data points. Our idea, like I showed earlier, is that you also benefit from adding the semantic IDs back into the original data systems in some form, whatever that is, because that brings you value as a company to just bring that back or play that back to the original systems. But if it's not possible, then of course it's not a big deal. You can still do that mapping in the plugin. In the end, like I said, the plugin needs to provide a semantic ID, but the data engine or the whole framework does not care about where that semantic ID is coming from. But ideally, we would encourage you to have a data source that has the semantic IDs attached, so that not only the TwinEngine can use the semantic IDs or the plugins for the TwinEngine, but also other systems could leverage that and benefit from having semantic IDs in the databases.
Okay. So is a question, I'm not fully clear about the background for that. How is it different from using the REST API calls from something like Postman for making changes to AAS? Maybe I guess in what direction. So as you have seen, we are exposing the AAS interfaces. We are supporting not all API calls that is defined like us, including write access to AAS. For simple reason, because if you would offer write access, you also would have to cover the transactional safe write to the, let's say, to the end system. So, and if you would, for example, would like to write back some data point to SAP or so, you would need to be very clear on that about conflicts, inconsistencies that you might bring up. For that very simple reason, that is why data fabrics usually are read access only. But if you would have the use case that you need some write access, then you would handle this separately. We could then create interfaces that do safely connect to these end systems, but it's not a generic offering or part of the TwinEngine framework itself. That's a very brief, but it's a complex things that you have to consider in architectural decisions.
And also to highlight here, in general, I can imagine the questions coming a bit from playing around with something like, for example, basics, which is a really good starting point, and we're also using basics for some components. But the problem there is if you use the AAS API from there, then you just add it in the basics repository, and if that value is then might need to get back into the original systems. For example, the CO2 value. You already have your MES systems and other systems, like it was pointed out earlier in a question. So you need to perform some aggregations and so to calculate that CO2 value, and that is not coming from the AES, from the standalone isolated repository there. It is coming from existing systems that already have existing processes around them, and they will be the single source of truth. So whenever you write through an API, you need to, like Rolf said, you need to make sure that this is done in a clean way, in a transactional safe way, and you cannot just push it into some isolated repository and then bring it back. That's way more complicated. And yeah, because we want to access and leverage the original, or the single source of truth and the real systems behind that are already there in the company. That's why we designed the framework to be like that.
Thank you. Next question. These RS examples are emulated and locally hosted for demonstration, right? They are not pulling data from an actual AAS server. I think, Hardy, that could be something for you to answer, because you have set up this demonstration and for sure that you have created that on your own or on your own environment, but you can let people know how that could be also connected to real life setups.
So I am using the local deployment. So this is the same example which is inside the example folder inside a data engine. So you can use that from there, and you can change the configuration, everything based on your need. So you will find same configuration inside our example inside a data engine repository, which I have present here.
Okay, thank you. This is a quite interesting question here. Is there a form of access or user management? I can't remember if this is discussed in the presentation. Who is to answer that one? Ankit?
Yes, at the moment, there is no special access or user management plan, but the AAS.TwinEngine support to work with whatever is already present and can be adopted, that one as well, as mentioned by Marcus in the slide earlier.
And Marcus, maybe you could extend this to the separate layers that we have to address here in security access.
Yeah, exactly. I mean, it really depends on what kind of user management you want to have, but we have that different layers here that I showed earlier, and they are tightly coupled to your internal systems. So we don't want to have an isolated access control and user management. We just want to reuse the existing users that are there and existing roles, and you can then just configure everything with that. So there's no special management for that needed.
Thank you. Here's a question which I think it's a follow-up question on something we've discussed already. Just give me a second. Which systems do you currently provide plugins for? What we have developed is a plugin which is connecting to Postgres SQL database. So it's a hard-coded or a coded plugin, because it is working based on a specific database scheme, and you could adapt it to your needs, to your specific scheme that you have in your organization. But so far, we have no public offerings for further plugins at this moment. And this will be depending on what customers are agreeing that they sponsoring what we would implement for them, and also if other contributors would like to create plugins and then also then sponsor to public.
And also technically, it's very hard to create generic plugins because we want to be that extendable to be. We want to create a generic framework for all kinds of data sources, and that always brings in the burden that we cannot cover everything. So that's why we chose to first go with a DPP plugin, because that fulfills a current need to just have a quick access to DPP. But also for that, it's just a reference. We provide with that a database with a fixed scheme, but in a production scenario, it would be better to if you bring in your own database and adapt the plugin to work with that database then, because then we have the single source of truth back in the original systems and not some copy in the other database. So yeah, that's the point with the plugin development, which makes it really really flexible, but also therefore a bit harder for us to foresee what's really needed.
Just as, let's say, a nice inspiration here, or just something that might be upcoming. You have seen at the beginning that we are connecting to data integration platforms, to data fabrics, and those data fabrics might come up with something like an enterprise knowledge graph, which is very common for such kind of, let's say, platforms, because a graph database can cover all the complexity of relationships across data points. And in such a case, you might be able then to have a GraphQL endpoint. So a we develop a plugin that is connecting through a GraphQL endpoint. That could be created generically based on some configurations, like where to find nodes in the graph which are matching the semantic IDs, for example. In the backend, it could be based actually on a graph database itself. It could be based on something like federated GraphQL microservice setup in your background. But it's now very much diving into architectural levels here. But we are open for your questions, your queries here, and we will follow up if you have some ideas. But at this point, would like to stop the question and answer session and come to the end. The end is this: we are now open. You can now access. Here is some. You can scan the QR code and. You can see the link here. Also, later we will share the recording of this session. Then you also get the links and so on, but you also can read it right there. Anything that you want to let us know, you can then respond to this email, and also here in the upper part of this screen, you can see there is a link which then takes you to the business, let's say, landing page of TwinEngine, where you also then can find our business contacts from business development, sales department, and so on. While this here is the tech, let's say that's the tech space, yeah, and anything related to development that you can ask here, raise your issues. Hope you will have a nice and easy entry to working with the TwinEngine, and whenever you have some issues, let us know. Here again, here's an additional channel that we are open. That is a more generic, let's say, email address that you can raise your questions, and we will route accordingly. So whenever you have a question that is clear, you can raise it as a feature request in the GitHub. But this is, let's say, fallback if you do not know whom to address. Just get in touch, keep in touch with us. So that's it. That was the openness session today. We will share the resources later on, and might also in future, that's depending on future directions, development, also plan for some follow-up sessions to this. So thank you. Thank you to the audience, to the speakers. And let's close here. Have a nice day. See you back on the GitHub.
Thank you.
Bye.
Bye.
Thank you.
Thank you. Bye-bye.